Vinayak, unmute yourself and tell me the screen is visible and audible. Hello? Hello, Vinayak? Hello, Vinayak? Unmute yourself. Rahul, unmute yourself. Hello?
Sir.
Vinayak. Hello?
Sir.
Screen is visible, you know?
Yes, sir.
And
Yes, sir.
audible.
Yes, sir.
Hello? 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 Hello?
Yes, sir, it is visible.
Hello? 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 Yes, sir. Screen is visible and audible, you know? Shall I start?
Yes, sir, it is visible.
Okay, okay. Hello? Shanti, ಸ್ವಲ್ಪ slow.
ವಾಯ್ಸ್ ಚೂರು ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಸರ್ ಅಷ್ಟೇ.
ಅಲ್ಲ ಇಲ್ಲಿ ನಂದು ಕ್ಲಿಯರ್ ಆಗಿದೆಯಮ್ಮ, ನಂದು ಲ್ಯಾಪ್ಟಾಪ್
ಇದೆ.
Last class we discussed about the measurement of negative pressure. The negative pressure, for that good example is if you have flask in your house, that's called a thermos flask. There will be two layers that in between two layers they create vacuum. They will not fill with any gas, they create vacuum so that the heat transfer between the liquid, hot liquid present in the flask, it will not be transferred to outside. So there is no heat transfer takes place in vacuum. So if you want to measure the negative pressure or low pressure, the only gauge is available is McLeod vacuum gauge. The only gauge which is available, McLeod vacuum gauge. See, all of you observe here. Last class I told you to write the diagram of a McLeod vacuum gauge. So almost all the question paper, you have a question on measurement of negative pressure or McLeod gauge. So in turn, you can have the question in the examination, measurement of low pressure. Measurement of low pressure. All of you observe here. What are the things present here? There will be two capillaries. One is measuring capillary, other one is reference capillary. You have to connect this measuring capillary, have a bulb like this, and which is connected to a reference capillary, which has the opening that you have to connect it to the pressure source, negative pressure source. And the measuring capillary and the reference capillary, in between two, in the center, there will be graduation. All of you observe here, that is 0 to 5. And this, both the capillaries are filled with mercury. So, and this tube is connected to flexible pipe and connected to a reservoir which contains excess or enough mercury. And this particular pressure gauge works on the Boyle's gas law. Boyle's gas law. The volume change is measured in terms of negative pressure. Volume change in the measuring capillary is measured in terms of negative pressure, that may be in bar or that may be in kg per millimeter square. That is the kg per millimeter square or in bar. First, connect this tube to the negative pressure source, and after connecting this, adjust the level of mercury in the measuring capillary and also in the reference capillary by pressing the plunger provided here, which connected to the piston in the reservoir, so that the mercury level in the measuring capillary and the reference capillary adjusted to zero. That is called null balance. That is called null balance. When you connect this to pressure source, what will happen? The negative pressure applies the force on the mercury so that mercury level in the measuring capillary moves downward direction. Note down the reading, maybe one, two, three, like this.
ಸರ್
The
ಇನ್ನೊಂದು
level
ಇಬ್ರು
of
ಜಾಯ್ನ್
mercury,
ಆಗ್ಬೇಕಂತೆ.
that is, please tell me.
ಜಾಯ್ನ್ ಆಗ್ಬೇಕಂತೆ
Hello.
ಸರ್ ಇನ್ನೂ ಸ್ವಲ್ಪ ಜನ.
ಹೌದಾ? ಸರಿ
Yes,
ಅಮ್ಮ.
sir.
ನಾ ಆಟೋ ಅಡ್ಮಿಟ್ ಕೊಟ್ಟಿದ್ದೀನಮ್ಮ ಎಲ್ಲರಿಗೂ.
ಓಕೆ ಸರ್.
ನಂದು ಪರ್ಮಿಷನ್ ಕೇಳೋದೇ ಬೇಡ, ಅವ್ರು ಆಟೋಮೆಟಿಕ್ ಜಾಯ್ನ್ ಆದ್ರೆ ಆಗೋಯ್ತು. ಆಟೋ ಅಡ್ಮಿಟ್ ಕೊಟ್ಟಿದ್ದೀನಿ ನಾನು. ಕೇಳು, ಜಾಯ್ನ್ ಆದ್ರೇನ? When you connect this end to the pressure source, that is a negative pressure, that pressure applies the force on the mercury present in the reference capillary as well as in the measuring capillary, so that the mercury level goes down. So that you can measure in the measuring capillary. See, all of you observe here, H, small letter H indicates the level of mercury. That is 3 in this case. And next come to the point. This particular McLeod vacuum gauge works on the principle of gas laws. Gas law, that is P1 V1 equal to P2 V2. P1 V1 equal to P2 V2. So the volume change V1 equal to P2 V2 divided by V1. So if you substitute the values of volume and pressure in the equation, you will get the negative pressure. The only instrument which is available in the market, that is McLeod vacuum gauge. From that you can measure the negative pressure. Next come to the point. See, almost all of you seen in the national highways or and sometimes the tankers which are carrying the gas one place to the other place. For example, oxygen, so which is transported from one place to the other place. All the major hospitals in the district headquarters which has the oxygen plant. Suppose in some taluk headquarters there is no plant for making of oxygen, so there you have to supply the oxygen through tankers. So the pressure of the oxygen in the tank is very less. Imagine that pressure is 0.05 or 0.06. In that level they fill the tanker with oxygen. That type of pressure in terms of microns, imagine, it's not in kg per millimeter square, it is in terms of microns that can be measured by using the low pressure measuring instrument that is called Pirani gauge. See, you are all belongs to mechanical engineering. The low pressure instrument, the low pressure measuring instrument is Pirani gauge. The low pressure in that case, negative pressure, that can be measured by using McLeod gauge, but the low pressure gauge can be measured by using Pirani gauge. Okay, there will be two containers or chambers or cells. There will be two cells. One is compensating cell, other one is measuring cell. Measuring cell, one is compensating cell, other one is measuring cell, which contains the resistances. In turn, this circuit is completed by electrical circuit which has one more resistance, and this is the receiver or recorder which shows the pressure in the tank. So usually this is the analytical type or digital type. So in that you can measure the pressure in terms of kg per millimeter square. The only gauge which is available for measurement of low pressure is Pirani gauge, so which contains two cells. One is compensating cell, other one is measuring cell. Compensating cell and measuring cell. All of you observe here what are the things present here. This is the measuring cell and this is the compensating cell. Here the pressure in the measuring cell, if it is more than the required one, then the compensation is required. So for that reason, there will be resistance that can be energized by the electrical current so that you can compensate if it is less pressure or more pressure, that we have to compensate by using one more cell here, the compensating cell. All of you observe here. Usually the power supply, that is 12 volts. 12 volts which is connected to the circuit like this, and in between that there will be two resistances which are connected parallel, is connected to the pressure indicator or pressure gauge or digital display which indicates the pressure. Once again, all of you observe here the principle of operation of Pirani gauge. Pirani gauge. So Pirani gauge has two cells. One is measuring cell, other one is compensating cell. Measuring cell is connected to the pressure source. So usually the pressure source is the gas tank or air tank, which is used to transport the gases from one place to the other place. So the gas filled in that tank is very less. So how much gas is filled in that tank, that is measured in terms of kgs, that is in terms of kg per millimeter square, that is low pressure. So all of you observe here, there will be two cells which contains the resistances and resistance like this, and it is the circuit is completed by using two more resistors connect like this, and these two resistors are connected, these two resistances are connected to the recorder or receiver, so which gives the pressure in the air tank. And this compensating cell and the measuring cell and the other line, con- other circuit line is connected to the power source. Usually this power source is 12 volts battery DC current. Usually in the vehicles we have 12 volts battery, so that the power supply is 12 volts, 12 volts, and this is used for measuring the low pressure, measuring low pressure. All of you, please write down the question. Please write down the question. Please write down the question. All of you keep a king size notebook and pen along with you. Please write down the question. How do you measure? How do you measure the low pressure? How do you measure the low pressure? Explain briefly. How do you measure low pressure? Put a question mark. Explain briefly. So next question on this same topic. Write down. Next question. Next same question. Same topic. The question is in different way. Explain briefly. Explain briefly with neat sketch. Explain briefly with neat sketch the Pirani gauge. The Pirani gauge. Or Pirani gauge. Okay, question mark. List the applications list the applications and limitations. List the applications and limitations. Once again, the principle of operation of Pirani gauge. The Pirani gauge is used for measuring of low pressure. See, this Pirani gauge is used in the vehicles which transport the gas from one place to the other place. For that, good example is oxygen tank or nitrogen tank or carbon dioxide gas tank. So which should transport the gas from one place to the other place. The gas filled in the tank is very low pressure because if they fill with high pressure, which may create damage to the tank. For that reason, the gas filled in the tanker or in the tanker is very less. First point. So, what are the things, equipment, or items present in Pirani gauge? First, come to the point. There will be two cells. One is measuring cell, other one is compensating cell. So measuring cell contains two resistances and compensating cell has one resistance. When you energize these two resistances, which changes the resistance that can be measured in terms of kg per millimeter square using receiver or recorder or digital display in the dashboard. You can observe the pressure of the gas present in the tank. Then the resistances are connected to one more resistance like this, and here the compensating cell resistance is connected to one more resistance. These two resistances are connected parallel by using recorder or receiver, and then the cell measuring cell and the compensating cell are connected to the power source or power supply. Usually, the power supply is 12 volts DC. 12 volts DC because this gauge is used in at, this gauge is used in tankers which transport the gas from one place to the other place. So this is the principle of operation of Pirani gauge. Next, come to the point. High pressure measurement of high pressure. Measurement of high pressure. See, in some of the cases, for example, boiler or air compressor or in a spectacular tank where you require high pressure air for manufacturing process. For that, your all belongs to mechanical engineering. Remember, high air pressure is required for injection molding. Remember, in manufacturing, injection molding requires high pressure air, which ranges from 0 to 500 kg per millimeter square. Remember, imagine the pressure required in injection molding, which ranges from 0 to 500 kg per millimeter square or 0 to 1000 kg per millimeter square. So that much of air pressure is required for injection molding. Injection molding. Say, you are all belongs to mechanical engineering. The injection molding is used for manufacturing of PVC items. Say you have buckets, tubs, mugs, and many more items which are used in the kitchens or manufactured from injection molding process. So that injection molding process requires very high pressure air, which requires high pressure air in order to inject the liquid plastic material into the die. There you require high pressure. So in that case, the air compressor produces the air with high pressure of 0 to 500 kg per millimeter square or 1000 kg per millimeter square. That can be measured by using the gauge which is available in market, that is Bridgeman gauge. Bridgeman gauge. All of you observe here. This is the Bridgeman gauge. And all of you observe here. This is the shell manufactured from stainless steel or low carbon steel. Stainless steel. This shell is manufactured from stainless steel or low carbon steel. All of you observe here. Safety stock of previous month will begin. And all of you observe here. This end you have to connect to the pressure source. This end you have to connect to the pressure source, and there will be a provision to connect this with the rod, and there will be a sensing element which is immersed in the kerosene. All of you observe here. There will be a bellow. Bellow means all of you have siphon of kerosene from tank to the container or jug by using siphon, that is used for siphoning of kerosene from tank to the bottle or container. For that, there will be a bellow which is manufactured from flexible material. Bellow which compresses and enlarges depending upon the pressure. Due to that, there will be a sensing element which is having sensor which changes its electrical resistance or electrical characteristics when the pressure changes. That can be measured by using terminals. You can connect these terminals to digital pressure indicator or analytical pressure indicator, which indicates the pressure in terms of kg per millimeter square. In terms of kg per millimeter square. So all of you observe here what are the things present here. This is the stainless steel or low carbon shell which has the opening. This opening has to be connected to the pressure source, and there will be a opening which is connected to a one more shell where you have the flexible bellow, and in the bellow is filled with kerosene, and there will be a electrical sensor which senses the high pressure, and the pressure is converted into resistance change, and again that resistance change is converted into voltage signal, and then voltage signal is converted into analog signal or digital signal that can be read by using analytical pressure indicator or digital indicator. So this is the Bridgeman gauge used for measuring of low pressure, which ranges from 0 to 500 kg per millimeter square or 0 to 1000 kg per millimeter square. All of you, please write down the question. Please write down the question. How do you measure? How do you measure? How do you measure the? How do you measure the high pressure? How do you measure the high pressure? Put a question mark. Explain briefly. Explain briefly. Hello? Is it audible now? Explain briefly. Okay. The very important question. Expect this question in the examination. All of you, please write down. Explain briefly. Briefly. With the neat sketch. Explain briefly with the neat sketch. Next, 36. 5,400 explain briefly with neat sketch. 3,800 divided by 168. The Bridgeman gauge. Explain briefly with the neat sketch. The Bridgeman gauge. Bridgeman gauge. Put a question mark. Explain briefly with the neat sketch the Bridgeman gauge. Put a question mark. Explain briefly with neat sketch the Bridgeman gauge. Put a question mark. List the applications. List the applications and limitations. List the applications and limitations. Once again, I repeat the question. Explain briefly with neat sketch the Bridgeman gauge. Put a question mark and continue the question. List the applications and limitations. All of you observe here. The Bridgeman gauge consists of the steel outer shell. Steel outer shell manufactured from usually using stainless steel or low carbon steel. And this shell has the opening. That opening has to be connected to the pressure source. And this shell has the opening and you can connect this to the sensor. The sensor is placed inside the flexible bellow. Flexible bellow. That bellow is filled with kerosene. And this bellow compresses and enlarges according to the high pressure. That sensor contains the resistance. Due to resistance change in the pressure, there will be change in the resistance. That resistance can be measured through the terminal. That resistance is converted into analog signal, and the analog signal is converted into voltage signal, and the voltage signal is converted into digital form or analogous form as it is, that can be measured in the indicator in terms of kg per millimeter square or in terms of bar. This is the principle of operation of Bridgeman gauge. Bridgeman gauge. Please, all of you. Please, all of you mention. This is very important. You can expect this question in the examination. So this is the principle of operation of Bridgeman gauge, and this is very important. You can expect this question in the examination. This is the last topic in pressure measurement. Shanti, ಸ್ವಲ್ಪ slow. So this is the last topic in pressure measurement. This is the last topic in pressure measurement. Now I will stop at this stage, and all of you please write your name and USN in the chat box. All of you, please write down your name and USN in the chat. Answer your call.